Welcome to Rosmaya Mohtar YouTube channel. Hi everyone, welcome to my YouTube channel. I am Madam Rosmaya. So today's video we are going to discuss on potentiometer. So there are two types of potentiometer. Okay, the top one is the rotary potentiometer and the bottom picture is the slide potentiometer. So we are going to concentrate on slide potentiometer in this discussion video. So get ready. A slide potentiometer consists of a uniform wire of length L in series with a driver cell D, in which L is usually 100 cm. It is the length of the ruler. A center zero galvanometer connected to a slider S acts as a null detector. Refer to the schematic diagram drawn here. So this is the cell D connected to a wire of length L, about the length of the ruler, 100 cm. And this is complete circuit. And the 2 points X and Y, where we are going to measure the potential difference, is connected to one end of the wire, and another one is connected to a zero center galvanometer and a slider. Let's say, let me call the slider S. So this S is moved until the pointer of the G read zero reading. And we measure the length made by the slider where the galvanometer shows zero reading. So let's say the length is L1. So the voltage across XY is given by L1 per L divided times VD, potential difference of cell D here. So we use potential divider formula. We have discussed the formula before in the previous chapter. And why we can use ratio of L? Because resistance of the wire directly proportional to the length of the wire. Because we use the same wire. Then from the equation or formula of R equals to rho L per A, so where rho is the resistivity of the wire, L is the length of the wire, A is the cross-sectional of the wire. So the resistivity and the cross-sectional of the wire is the same because we use same wire here along the ruler. So therefore R is directly proportional to L. So instead of using the ratio of resistance, we can use ratio of the length of the wire. So we use L1 per L. Okay, from the equation here, so V is directly proportional to the length of the wire. So L is constant because it's the length of the wire, the length of the ruler, okay, equals to length of the ruler, 100 cm. And VD also constant. It comes from the voltage of the cell D here. So therefore, the voltage across XY here is directly proportional to the length L1 here. Length. Generally, we write as V directly proportional to L. So we can put whatever load here where we are going to measure the potential difference across them. Example, if we want to measure the potential difference across the another cell, unknown cell, let's say E1. Okay? So you can put it in between X and Y. So you can get the reading or the value. You can calculate the value of the E1 here, okay, by using the formula L1 divided by L times the VD. Okay, now refer to the animation given here to get the idea how the galvanometer points to zero reading. So we slide the slider S along the wire until the pointer of the galvanometer shows zero reading. Then we get the length of the wire L1. Okay, the potentiometer is used to measure potential difference, okay, accurately. compared to using voltmeter to measure the potential difference. So we can make adjustment for the potentiometer to measure the EMF of a cell. This is what we discuss in the next video. Okay, the first potentiometer, we can make the arrangement to measure the circuit here to measure the EMF of a cell, or you can make the another adjustment for the potentiometer just now, okay, to measure the EMF of a thermocouple. Okay, you can see the difference here where we put the resistance here. Also, we will discuss this in the next video. And the third one, the potential also can be used to measure the internal resistance of a cell. Okay, this is the adjustment made. Also will be discussed in another video. And finally, we can use the potentiometer to compare resistances. Okay, so see you in the next video. Bye.